Okay.
All right. So for activity A, yeah, so we're just making a graph.
Mhm.
Create graphs with the following characteristics. One global maximum.
Yeah. So,
Okay, that could just be like an upside down parabola.
yeah, that works. And then the next one has global minimum of one, and then a local maximum of one. Okay. Mm.
So he needs, so okay, so a global minimum and a local maximum. So, and another and a local minimum. So if we had a global minimum, then it would go down really far. A local max, so it would go up. And then another local min would go down, but not nearly as far as the local minimum. But since we have a global minimum, it needs to go back up. And so it would kind of be like a loop. It would go down and then up and down and then back up.
Okay.
Or vice versa, down a little bit, up, and then down really far, and then back up. That could
Yeah.
work too. Um, so see the next one, a local maximum and a local minimum. Could probably just do like a cubic function for that one. Oh, oh, that's interesting. Local maximum and
So,
two local minimums. That's weird. Oh, okay. I just clicked on the answer key, and it like they have like an isentope, and then like two sections of the graph.
okay. So that way there can
Makes
be
sense.
two local minimums.
Mm-hmm.
There's a different. Okay.
All right. Global or local max or mins. So a straight line that could work.
For all of them are zero. Yeah.
Um, let's see. Next one. A global maximum, one global minimum, and no local or maximums, no local minimums. Okay, so just like,
Well, would it just be like, I don't know, a line and then go down and then up? Would that work?
yeah, they go down and then up,
Yeah.
and then yeah, just so long as like it as it went to infinity, it wasn't lower than um, the minimum or higher than the maximum.
Okay.
So then there's one global maximum, one global minimum, a local maximum, and a local minimum. So it's kind of like the same graph as the one before, but like you just have a few extra loops that weren't quite as drastic as the globals. You just have to make sure that the um, as it went to infinity, it didn't go higher or lower than the global maximums.
Okay.
So the next one, you have a global maximum, two local maximums, and 0 local minimums. So it would go to infinity,
Yeah.
to negative infinity for no local minimums, and it would have to go to infinity for no global maximums. But since there aren't any global minimums, we can't have a bottom loop. So it would have to be 2 up loops. Maybe it could connect at a point, or maybe there's an asymptote between the 2 of them or something like that.
Okay.
So the last one is no global maximums, 1 global minimum, no local maximums, and 1 local minimum. So kind of like the same thing as the last one. So it will, except since there's a global minimum, it won't go to negative infinity, but it can go to positive infinity because there's no global maximum. There's no hump. There's no concave down section, but there'll be 2 concave up sections with one of them being lower than the other. So maybe they could connect to a point or like have an isotope between them.
Okay.
So, and there's under what circumstances do maximums and minimums happen?
Yes. When they change from positive to negative. That makes sense because they're going up. Once they
Yeah, I think when like the slopes change.
Yeah.
So suppose a function is continuous and defined only for x values on the closed interval -1 to 1. Is it possible to have no maximums or minimums?
Is it no?
I would say no, unless it, I mean, even if it was like a straight line, like a horizontal line.
But there's, yeah, because even if it's a straight line, it has a closed interval. So,
right.
The endpoint.
Unless it went to, yeah, no, even if it, I mean, the only situation I can think of that it might do it is if there was a function that had vertical isotopes at -1 and 1. And it's in a closed interval, and the interval notation says that -1 and 1 are included. So yeah, no. Are not included, then you could.
Yeah.
But so if a function is continuous, is it possible for the function to have 2 or more maximums without any minimums? No.
No.
Makes sense. Cool.
Okay.
So that's activity A. Any questions there?
I don't think so.
ready to move on to activity B.
Okay. I'm just looking at it, trying to figure out.
Yeah. So it's asking for all the intervals where it is increasing or decreasing. So we just need to, if we find the derivative, we can then figure out when the slope, like when the values of the derivative are negative, we could set it to equal to 0. And then solve for the points. And then those points would give us the x-intercepts. And so then we can pick a number below, like in, not on those points, but like just before, just after them, to figure out if it's positive or negative. And then if the number that we plugged into the derivative is negative, then it's decreasing. The original function is decreasing. If it's positive, then it's increasing.
Okay.
So the derivative is, so we got 3x squared minus 3x. So we can factor out a 3x. So we're left with 3x times x minus 1 equals 0. We can do x equals 0 or x equals 1. So then we can plug in those numbers. We're left with we have negative infinity to 0, 0 to 1, and then 1 to infinity. And so if we plug in, say, negative 1 into the derivative, we get negative 1 squared is just 1 times 3 minus 3 times negative 1, so plus 3. So it's a positive number. And so it's increasing on the interval negative infinity to 0. If we plug in, say 2, then we have 3 times 2 that's 12 minus 3 times 2 are 6. So 12 minus 6 is 6. So that's a positive thing. So it's increasing on the interval 1 to infinity.
Okay.
And then if we plug in 0.5, 0.5 squared is 0.25 times 3 is 0.75 minus 1.5 is negative 0.75. So it's a negative number. So it's decreasing on the interval 0 to 1. Does that make sense?
Yeah.
Cool.
Okay.
So then the second one.
X. And cosine x.
So we've got we have the derivative is 1/2 minus cosine x equals 0. So we get when cosine x equals 1/2. So then we can solve for pi over 3. So then we intervals of 0 to pi over 3, pi over 3 to 5 pi over 3, and then 5 pi over 3 to 2 pi. So you can just plug in numbers. So we know that cosine of anything below, let's see, well, cosine between 0 and pi over 3 is greater than 1/2. So that's going to be a negative number. So it's decreasing between pi over 3 and 5 pi over 3. It'll be a negative number. And so that'll end up being positive. And then from 5 pi over 3 to pi over 2, it will be a positive number that's less than, that's greater than 1 over 2. So it'll be a negative, so it's decreasing on that interval again. Cool. Like 2/3. Okay, I was like, for question 3, I could not find, I couldn't see what the exponent was. It's a 2/3. So we can use the chain rule, 2/3 times x squared minus 4 to the negative 1/3 times derivative of x squared minus 4, which is just 2x. Set that to 0. So looks like it's 4x over 3 times x squared minus 4 to the 1/3. So we have to check to see when it equals 0 or when it's undefined. So when the numerator equals 0, then we just need x equals 0. When the denominator, or when it's undefined, equals 0, see, we have x squared minus 4 equals 0, so then we can do x squared equals 4, so x equals plus or minus 2. And then you just plug those in and figure out the intervals. And then, oh, the last one that gets complicated. Let's see. So we have x squared times 4x to the 3rd minus 2x times x to the 4th plus 1 over x to the 4th. Let's apply that out.
Or x to the 5th minus 2x to the 5th plus 2x.
What was that again?
Or x to the 5th minus 2x to the 5th plus, or wait, minus 2x.
Okay. Yeah, I was like, I got a minus 2x over x to the 4th. So then we can in the top, we can factor out a 2x. 2x times x to the 4th. Let's see. Oh, I see. Okay. So we can.
Oh, so simple.
We can 2x to the 5th minus 2x. So we can do 2x to the 5th minus 2x. And then we can factor out 2x. With this one. And we can set that to 0. So we can say x equals 0 or x to the 4th equals 1. So x to the 4th can equal positive or negative 1. And then when it's undefined, we just need x equals 0. So I already have that. Right now. And it just looks odd. She has an increasing from negative 1 to 0 and from 1 to infinity. She has it decreasing from negative infinity to 0, which overlaps with the increasing value that she has here.
Yeah.
So I think she may be meant to write negative infinity to negative 1 and then 0 to 1. That would make a lot more sense.
Yeah.
I think that's it.
So,
Cool.
see you next week.
Yep, sounds good.
Okay. I'll just
Bye.